Hello, this is my attempt to make a video about my construction of a free sailing model yacht. Free sailing model yacht is one that doesn't have radio control. The only controls are presetting on the sails, put it in the water and let it go. The idea came to me because I was up at Southwold, one of my favourite Suffolk towns, watching people racing their yachts on Southwold Pond. In discussion with a friend of mine, my next door neighbour Ed, who happens to have a yacht he used to sell with his grandfather many years ago, and another friend Charlie, we decided to challenge each other to a race. Now, my next door neighbour Ed, he's got a yacht he used to sail with his grandfather. It's about 26 inches in length, plastic construction, and after I re-rigged it for him, it sails quite nicely. Now, my friend Charlie has managed to purchase a second-hand yacht from Walberswick and is adjusting it to maximise its performance. Now, being a almost fully retired engineer, I quite fancy the challenge of building my own boat. But I know nothing about boat design, and actually not a lot except for static models of building model boats. So the first thing I do is, of course, to get some plans. Now, I obtained some plans from the nice people at Sales Etc. in Essex, and I got two sets of plans. One are construction plans for a yacht called Nimbus, which is an international 1 metre class, and then some line plans, which are basically sections of the hull showing you the full shape of the hull. The problem with these plans is, being a international 1 metre, they're quite large, and I wanted to go for something closer to the 26 inch length. So the first thing, get the plans and then scan them. Now, what you end up with when you scan them is a PDF, which of course is a raster format, not a vector format, and my drawing package is ProgiCAD, a AutoCAD lookalike, which requires vector drawings. So, as an aside, and for you who out there wish to try this, you'll need to use an online converter to convert from the PDF from your scan to an SVG drawing, and then from an SVG drawing to a DXF or DWG drawing. And then you can import it. Once imported into ProgiCAD, I could scale the drawing by a factor of 2/3, and I've then got my plans. So let me just show you some of the plans that I'm going to be using. Now, this is the model, the Nimbus Mark III, that I have the construction plans for. No sections of the hull, but it shows me how all the different bits are meant to go together. But remember, this is a radio controlled model, so it's got lots of details which will be unnecessary in my model. Now, the model I'm actually building is called the Vector, also from Sales Etc. And as you can see, we have sections of the, sorry, I'm standing in the shadow, I'm new at this, sections of the hull, cross sections through the hull, and a side view and sections. Now, this is the main plan I need to use to construct the hull. And the method I'm going to use is called the bread and butter. And I'll thank a very nice gentleman on YouTube who showed me this construction method. From this plan here, these contours are in 10mm intervals. Now, 3 10mm intervals on these plans will be 30mm at 2/3 scale, which is what I'm going to build. That will require 20mm sections of wood. And what I've done here is printed out 4 sections at 20mm height that I can use for patterns for cutting out my timber. Hello, so now I'm going to show you how I'm going to mark the boards out and cut the boards for hopefully an aligned assembly. I've laid the section plans out on a piece of 20mm thick tulip wood. The reason I'm using tulip wood is it's got a nice fine grain, it's easy to work, relatively soft, and also I happen to have a bit left over from another project. Good reason. So here you can see I've laid the plans out and I've cut the plans such that there's a couple of millimetres, they are a couple of millimetres larger than I actually need. And I'm going to mark round the edge of each plan with a marker pen, so I know that when I cut them out with a jigsaw, they won't be larger than I actually require. Now on each plan, I've marked 3 dots. 1, 2, sorry, 4, 3, 4. And the purpose of these is I'm going to put most likely a piece of M4 studding through all of the sections so that they are nicely aligned when I come to glue them all together. I have put them on the centre line. I know that there's some people prefer off the centre line, but I've avoided the areas such as in the middle here where the keel and mast will be. So hopefully that will be okay. I'll also be machining out these sections, 20mm thick sections, to improve the displacement, because I shall then be adding a lead keel weight, and obviously the more vertical the yacht, the better it will sail. So I finished marking out the timber, so I know where to jigsaw inside and outside of the 4 sections, and I'll show you the results. The first thing that I realise is some of my holes where I'm going to register, the registration holes, register the 4 boards together, were in areas that would not exist after I've jigsawed everything out. But hey ho, that's how we learn as we go along. So let's have a look at the layout. So this is the top section, and you can see the black line is the internal jigsaw line, but if I did it to that line, it would actually go through the hull, so I have to be at least 5mm inside that line. At the stern section, I'm leaving this area clear for fixing, well, to provide 1 registration hole, and also because the rudder is at the stern. In this area, I'm leaving a section for a bulkhead for strength, and across here for the mast and for the fin keel. Similarly, on the second section, registration, so leaving the bow with some strength, and also the stern. And then the third section, 2 new registration holes here, which match up with the registration holes in the bottom section, because the earlier ones I did ended up in what will be fresh air. So I think I'm just about ready to start cutting. And then of course after I've done that, I shall realise the other mistakes I've made. Oh, I should mention on here, on the top section, it's only 15 deep, because obviously I want to have the whole boat waterproof, so I'll need to leave 5mm thickness, and I shall router that out rather than jigsawing it out. Okay, time to go and do some cutting. Well, hello again. So I think it's time I sort of explained some of the processes that went through my mind when trying to design how I was going to build this model. And one of the first things I had to look at was scaling. The model I'm building is scaled at 2/3 the size of the original plans. And that creates some issues that I don't really understand, because I'm not a boat designer, but I'll try to explain my thought process. This is a model of a yacht I made a few years ago, and imagine that this was the yacht of the plans I'm using, and I then scale this model down by a factor of 2/3. Now the first thing that happens is the volume and the weight, the displacement, will scale by the cube of that. And the cube of that is about 30%. So when the boat is sailing and the wind is pushing against the sails, the weight, the force that's trying to correct the tilt of the boat, the yaw of the boat, is the weight times the distance from the centre of displacement of the boat. And the weight will go down as the cube, as I explained, of the scaling factor, and the distance will be linear to the scaling factor. So we have a moment trying to correct the tilt of the boat of a factor of the power 4. Now, however, the wind hitting the sails that's trying to force the yacht over, the sail area will go as the square of the scale, and the moment will be from the centre of force on the sails down to somewhere in the hull, which is linear. So we have a scaling factor of a factor of 3, x cubed. So we have more force trying to push the boat over than it is trying to correct it. So we can correct for that by making smaller scales than a scaling of smaller sails, than a factor of 2/3. But to do that, we also want to make sure that we maximise the righting force of the keel. Now, in that case, having a solid hull built out of solid bits of timber means there's a lot of weight in the hull, and therefore we'll only be allowed to have a little extra weight, possibly, on the fin keel. I would like much more weight on the fin keel than in the hull. And to do that, what we're going to do is try and hollow out these plank sections that I'm making so that there is the minimum amount of material for the shape of the hull. So what we're going to do is, onto each of these sections that I've drawn on the plan, I'm going to mark not only the outer, which shows the top, the larger dimension, but the smaller dimension for the underside of each plank, using the same patterns. And then I'm going to jigsaw out most of the timber in the middle. I'm going to leave a bulkhead section to provide more rigidity, and also I need somewhere that I can lock the fin keel in and the mast in. So I'm going to mark that out on this drawing, on this the timber now, and we'll have a look at what we end up with.